Hi everyone, welcome again. In this video, we will develop a Spring Boot API from scratch to manage the to-do items. So we will expose 4 endpoints. Number 1 to post a to-do item, a task. Then another endpoint to fetch all the to-do items which were created as part of the post request. Then we have couple of more get endpoints to find the to-do items by a user or the creator who created that to-do item. And the last endpoint is subset. It's not exactly a subset, but we will see how to implement paging and sorting. And for all these calls, API will talk to the database, MySQL in this case. So we will save all the data in the MySQL. Then we will fetch the data from the MySQL using Spring Data JPA. So let's get started. So the first step is to set up the database. If you don't have MySQL and if you want to follow along, you can watch this video or you can find the link in the description. In my case, the database is up and running, and if I go to the workbench, here we have some existing databases, but for this demo, we will create a new database, a new schema, and we will name it task DB. Apply, and it will create a new database, which is empty right now. There are no tables. So we will use Hibernate feature to create the tables automatically when we run the API. The second step is to set up the API codebase. To do that, I'll go to my IntelliJ. We'll create a new project. It's going to be a Maven project. Artifact. So we will name it task API. Hit next. I need to change the package name. Hit next, and now we need to add the dependencies. This is going to be a REST API. So first of all, we need to add Spring Web dependency. Second, we need to add the MySQL connector because we are using MySQL database. So just search MySQL and this is the driver which we need to add. The third dependency that we need is Spring Data JPA because we will be using Spring Data JPA to talk to the database. Spring Data JPA, this is the one. And that's all we need from the dependencies perspective. Hit next and create the project. This will now set up the project. Let's give it a minute or two so that it can download all the required dependencies. Okay, so the setup is complete. Now let's quickly verify the pom.xml. Here we have all the required dependencies: starter data JPA, boot starter web, and MySQL connector. All right. Now let's go to the application.properties file. And for now, I'll change it to YAML. This application.yaml file is currently empty. There are no properties. Let's give it a try. Let's start the server as of now. So I can run my main class and the server startup failed. It says it cannot find the data source. It cannot locate the database. The reason is we have added the dependency of Spring Data JPA, but we have not provided any database configuration. So next we will provide those configurations in the application.yaml file. Spring.dataSource username. Because I'm using the root user, so I will provide my root user's credentials. If you are using a different user, then you need to provide those credentials. So my username is root, password is, and we need to provide the URL where the application would find the database. Let me quickly paste the URL. Here it is. And now we need to provide the database name. Let's check the database name. This is taskdb. And that's what we need to give here. Okay, so the URL is saying this is a MySQL database and this MySQL server is running on localhost, this port, and this is the database name. Next, we will provide a couple of more properties related to JPA. So jpa.hibernate ddl auto create. By setting ddl-auto to create, we are saying please create the schema or the required tables at runtime. So Hibernate will take care of that. This is only for the demo purpose. We don't use this property in a production database. Now that we have provided the configurations, let's retry the application and let me rerun. And we can see the API is up and running now. Although there is nothing to do, there are no controllers, so this will do nothing. Moving on, let's add a new controller so that it can service the requests. To do that, I'll add a new class and we will name it REST controller. We need to add the annotation REST controller. We will also add a mapping, request mapping, and the root URL pattern for this controller will be task. Let's quickly check the diagram that we are going to cover. So we need 4 endpoints. One of them is post and other 3 are get mappings with these URLs. So let's add the skeleton methods and then we will write the logic as we progress. The first one is going to handle the post request. For now, we will return nothing and let's name it create task and post mapping. And notice in the diagram, we are using this URL pattern task, which is the root URL or the base URL of the controller. So we don't need to explicitly provide this mapping here. It will be derived from the controller. All right. Let's copy it and paste it here. The second method that we need to provide is for the get mapping for the same URL pattern. So again, we don't need to provide any additional URL pattern here. All we need to do is we need to change the annotation to get mapping to support the get calls. And we can change the method name to tasks because we will return all the tasks from the database in this method. The third endpoint is to return the to-do items by the user or by the creator. It's going to be a get call. Let's copy the method again. It's going to be a get mapping, but notice the URL pattern. We need to provide the user as well. It's going to be a path variable. So we need to add a URL pattern here like this, user. And then we will bind this path variable to this method argument, user. All right. And the last endpoint is again a get mapping or HTTP get endpoint, and it has this URL pattern task/subset. And we will copy it again. And this time we will change it to subset. We will change the method name as well. And for now, let's remove the method parameter. We will add the required parameters when we develop these endpoints. So we have added all the required endpoints in this controller with relevant methods. We will change these methods. We will enhance these methods as we progress. We have the skeleton ready. Now let's start implementing the methods. This method will be used to create new items or new tasks in the database via this API. First thing we need to do is we need to add the request body annotation in order to consume the request data. The client would send an HTTP post request and the request would have some data, basically the tasks that we need to create and load. This is going to be request body. Then we need a POJO, a model to hold that data. Let's name it task post request. It does not exist yet. We will create this one. Then we will write some logic to create or insert these tasks. And in the end, we will return a response. Let's now add the request first. This is going to be a class and we'll add a new package. What all fields do we need in a task request? So each task for this demo, each task would have 3 to 4 properties and we will add those properties. The first one would be title. Second one would be a priority. 1 to 5. We can also have an enum to define the priority, but for this demo, we will simply keep it as an integer value. The third property would be created by, who created this to-do item. And the last property would be its description, a small description. All right. Now let's add the getters and setters and a toString as well in case we need to print it. That's it. So that means each post request would have a single task request so that we can add one new task in the system. Alternatively, we can also accept a collection of tasks in case we need to add items in bulk. We will do that. So list, we will accept a list. That means the user can provide multiple to-do items. We will accept them and we will add multiple items in bulk in the database. Once we have the request, how do we add this data to the database? To do that, we will add a new service in the system, which will represent the service layer of this API. So the controller will accept the request, but it will delegate the responsibility of processing to the new service. And service, with the help of the repository, will add the data to the database. All right. So let's add the new service. we will auto wire this service. Let's name it task service like this. And we will add the task service now. We'll create a new class in the service package. And we need to annotate it with @service. Okay. And once we have the service, we will call add all. And this add all method would accept the list. This add all method doesn't exist in the task service. So let's add this method in this service like this. Once we are in the service, it will work with the repository, but we don't have the repository. So let's add the repository as well. And in the same way, when we have the repository, we need to auto wire the repository in this service so that we can use it. And we will name it task repository. And now we will create the task repository. This is going to be an interface because we are planning to use Spring Data JPA. And in Spring Data JPA, it is super easy to create the repository. All we need to do is we need to add an interface and it will extend a particular interface from the Spring framework. And if we do that, we won't have to provide the simple CRUD operations, the implementation of simple CRUD operations. It will be auto-generated by the Spring framework. Let's add a new package. And in this one, we will create the repository. Now this repository will extend JPA repository. The first argument is the entity that we don't have. Let's name it task entity. And the second argument or the second type parameter is basically the data type of the primary key, which is going to be long in this case. All right. Now we need to add the entity as well because we are using Spring Data JPA. So this entity will be saved in the database. Let's create the task entity now. And what fields do we need in the entity? If we go to the request model, we need to save title, priority, created by, and description. Apart from this one, we need the identifier or the primary key as well. So we can simply copy the properties and paste it here in the entity class. And additionally, we will add a new field for the primary key ID. Okay. Let's add the constructor, select none, default constructor. Then we need to add getters and setters. And we also need to add equals and hash code. Next. So we have the equals and hash code, all the getters and setters, default constructor. Now we need to annotate this entity correctly. Otherwise, Spring Data JPA won't be able to identify it. We will annotate it with entity annotation. And this is the primary key. So we need to add ID and generated value. That means this is the primary key. And we are asking Hibernate or the Spring Data JPA to generate the primary key automatically. So we have the entity as well. And let's go back to the repository. This is the repository now. We are using JPA repository because we need to implement sorting and pagination as well. So we'll go back to the service. Once we have the task repository, we can use the task repository to call save all, which will basically accept a collection and it will insert the items in bulk. This one. We have this list, but we cannot use it directly because the save all method expects an entity, which is this one, task entity. In this particular case, these two models, which is task entity and task post request, these are relatively same, almost same except the ID attribute. But in a real project, the request model and the entity could be very different. And that's why we keep two different classes, one for the entity and one for the request. For instance, in the future, let's say there is a change in the task entity, which is required for the database communication, but that's not needed in the request. In such scenarios, keeping both models separate would make sure that we don't make unintentional changes in different entities. So let's go to the task service. We need to convert this list of task post request to a list of task entity. List of task entity. We can name it task equals to post request map to list. Now we need to convert the task post request to task entity. Okay, and we will initialize a new object of task entity. That created by en.setPriority. Set description. And then we need to return this en. So we have converted this incoming collection to a collection of task entity, and now we can pass this collection to the save all method, which would insert all this data in the database. This save all method returns a collection, basically a list of items which were added as part of the DB call. And for this demo, we will return the size as a response. So we need to return it, change the return type. And if we go to the controller, here we have the count of inserted tasks. As of now, we are not returning any response back to the user, but for this demo, we will return the number of inserted records. And to do that, we will create a new entity, task post response. We don't really need one, but I just want to show you how can we work with request and response models. That's it. So let's create this model as well in the model package. And this would have a simple property, which is the inserted count, inserted records. Okay. And we'll go back to the controller now. And we will set the property. And then we can return this response. And from the previous lessons, we know we can also return the response entity in this case. So instead of just returning the response, we can return a response entity here. Before we try out the implementation, let's quickly recap what we did. In the create task method, which would handle the HTTP post call, we are accepting a collection of requests, a collection of tasks that need to be added to the database. Then we defined a service, created a service. We are calling the add all method of the service, which is returning the count of inserted tasks. And we are returning this count back to the client in the form of task post response. If we check the implementation of add all, it is converting the incoming collection to a collection of task entity, which is the JPA entity. And then we are simply calling the task repository save all method. We are passing the collection, and in the response, we are returning the count of inserted records. Let's start the service now, and we will submit a list of to-do items, and then we will verify if those items were successfully added to the MySQL database. Let me start the service now. The server is up now. I will now open my Postman to submit this post request. In the Postman, we will add a new tab. We will change the method to post because it's going to be a post call. Then we need to provide the API address, which is localhost:8080, and the endpoint. The endpoint in this case is tasks. And then we need to provide the body. It's a post request, so we need to provide all the items that we want to add in the body. And to do that, we will select JSON, and here I will paste the request. And remember, in the controller, we are accepting the collection, so we need to pass the collection. We can pass multiple post requests here. And this represents an array, and here we are passing multiple items in this array. So this particular block represents a single task. It has all the properties: title, priority, created by, and description. That's what we defined in the request model here: title, priority, created by, and description. So in total, we are passing 6 records, And if we hit submit, it should insert all these 6 items in the database, and in the response we should see the count 6. So let's hit the send button, and we got an error because I misspelled localhost. Let me correct this one and retry. And we got the correct response. Let's verify in the database. If we refresh the task TB now, and here we see the table name as task entity. Why this name? Because in the code base, if you go to the entity, this is the name of the class. We have not overridden it. That's why the name is task entity. Let's read the data from this table, and we see all the 6 records inserted in the database with ID auto-generated. So we successfully inserted the data in the database using HTTP post call. The next step is we will implement the get endpoint to read this data in bulk. Let's go back to the controller, stop the API for now, and we will go back to the controller. And this time we will start implementing this method, which will service HTTP get call, and it will return all the items from the database. Because this will return all the items from the database, it will not accept any criteria, any filter criteria. So we don't need to provide any method parameter here. All we need to do is we need to call this service again, and we will say fetch all like this. This method does not exist. So let's create the method in the service. And in this service, we will use task repository, and task repository has a method which is find all. All of these methods are generated and provided by the framework. So we will simply use this method find all, but the problem is this returns a list of task entity, and as we kept the request model and the entity different, in the same way we need to create a response model that can be returned back to the client, because we don't want to expose the internal entity, which is the JPA entity. So we will store this in a list of task entity. We will now create another model to hold the task detail, and we will name it task detail. This will be a list of task detail. It represents the details of a single task. So let's create this model as well in the model package. And it's going to be exactly same as the task post request, because we will be returning the same number of fields. So let's copy the whole class and we will paste it in the task detail. And we can change the name in the toString method here. Because this is just a demo application, so we see this overlapping of fields across all these models. But in a real life project, these could be very different from each other. Let's go back to this service, and now we will convert this list to a list of task detail. Okay. And we can simply return it from here. All we need to do is we need to provide the implementation of map to convert the task entity to task detail. And to keep it simple, let me go back to the task detail, and we can add a default constructor first of all, and another constructor with all the parameters, so that we can quickly create the task detail. Okay, now we will go back to this service and we will write the conversion logic. We will say task detail, and we need to pass all the parameters. So the first one is entity dot get title. The second one is entity dot get priority. Third one is entity dot get created by, and the last one is entity dot get description. Let's verify from the constructor title, priority, created by, and description. Okay, and we need to change the return type. So in the service method, we called the find all method of the task repository, which returned a list of entities. Then we are converting this list of entities to the list of task detail, which will be returned to the task controller. And from the task controller, we can simply return the response back to the client. Let's change the return type here as well, list of task detail. let's now run the application and test this call as well. The server is up now. Let's verify the data in the database. If we trigger the select query, we see the data has gone. The reason is because we are using DDL auto equals to create property. So that means every time when we start the application, the data will be wiped out. So we need to post the data again in order to test the get call. That we will do here. The API is running, so we will use the same post call that we did earlier to insert the data. All these 6 records have been inserted. Verify in the database. We see the 6 records. And now to test the HTTP GET call, we will add a new tab. This is going to be a GET call. We don't need to provide any other parameter. And if we hit send, in the response, we would see 6 results. These are the 6 items that were added as part of the post request. Or these are the 6 items which are currently in the database in the task entity table. So we successfully implemented post mapping. We successfully implemented get mapping as well. As a next step, we will now implement this method which will return the tasks of a particular user. This method is pretty similar to the fetch all method. The only difference is in this case, we will be passing a user and we will fetch the items of that user. To read the user from the incoming request, we are using path variable here. So let's write the logic to fetch the items where the created by is this user. We will start with calling the service again, task service dot fetch by created by, and we will pass this user. And let's create this method in the service, fetch by created by. And here we need to call the repository and we need to pass this created by user to fetch all the items from the database. Let's see if there is any method in the repository that we can use to filter the records based on the created by. So I will do task repository dot find. And here we see many methods that we can use actually, like find all by passing an example. Although this one is find by ID because that's the primary key. But this time we will try something else. We will define the criteria in the repository and the implementation will be generated by the Spring framework. So let's go to the repository. In this interface, we will add a new method that will return a list of task entity. And the name of the method is important because based on the name, the framework will generate the code. So we will name it find all because we need to read multiple records. Because we need to apply the filtering as well, we will provide the keyword by, find all by, and then the name of the property which is created by. And we need to pass the value that will be used in the where clause, which is a string value created by. Okay. So we defined a method in this interface by following a naming convention, find all by, which is the keyword which represents a where clause. And then we are providing the property name to use in the where clause. And the value that we pass to this method will be used in the where clause when the Spring framework generates the query. So we'll go back to the task service and we will say find all by created by the new method and we will pass the user. This will return a list of task entity by user. And once we have this list of task entity, we need to do the same conversion here. So I will copy this part from the fetch all method. And we need to change this one. We need to change the return type. All right, let's go back to the controller and we can return the same collection back to the client. So we have the implementation ready. We are accepting the user using path variable because that's going to be a path variable. Then we are calling fetch by created by method of the service. And from the service, we are calling the new method that we added in the task repository, find all by created by. We are passing this user, but we have not provided the implementation. Based on the naming convention of this method, Spring framework will generate the code. Okay, let's start the API and test the new method. So the service is up and because the data has been wiped out, we need to post the data again. To do that, we'll go back to the post request. We will add the data again. The 6 records have been inserted and this time let's pick a user to test the new method call. This is going to be a get call. The URL pattern will be tasks, but after that we need to provide the path variable, which is the username, user2 in this case. And this time when we hit enter, it will fetch all the items of user2. And here we see all the items of user2. So that means the new method is also working fine. So we have correctly implemented 3 methods in the task controller. Let me stop the service. And the last remaining method is subset. Although the name doesn't justify the implementation, in this method we want to return the records, but we will allow the user to pass the sorting order and the page number. So that means when the client calls this API endpoint, it will provide some more details. And depending on the provided property, we will sort the collection before returning the collection back to the client. Along with that, user can also identify the page number because we will be implementing paging. And to implement this method, we will accept 3 parameters from the user. And that's going to be request parameter. The first parameter is going to be order by field, which means by which field you want to sort the elements. The second property is also going to be a request parameter, and this is going to be the direction, ascending or descending. So we will name it direction. And the third parameter, which is also going to be a request parameter, is going to be an integer property, and this is going to be the page number or simply page. And we will make them optional. We know how to do that. This annotation has a default value. So if the user does not provide any field, we will use title. What about the direction? This is going to be optional as well. And by default, the order will be ascending. And same with page, the default value would be the first page, which is 0. The page index is 0 based. So by default, we are passing the page as 0, which means the first page. Once we have all the required parameters, following the pattern, we will call the task service and we will name a method subset, let's say. And then we will pass all these parameters to the subset method: order by, direction, and page. Let's create this method in the service. Now we will use the repository to apply the paging and ordering. To apply the paging and sorting, we need to have a pageable, which is coming from the Spring Framework data domain. And for that, we need to initialize page request. This page request has different static factory methods, as you can see here. Now, for example, if we don't need to apply the sorting, we can use this one, which accepts page number and the page size. Page size is basically the size of a page, and depending on the page size, page number is derived. So for example, if we have 60 records and if we define the page size to be 10, then we will have 6 pages, and the page number will be from 0 to 5 because page numbers are 0 index based. Because in this case, we have 6 records in the database, so we will define the page size as 3. That means there's going to be 2 pages with indexes 0 and 1. And we need to use the sorting as well, so we will use this method. The first one is the page number. So we will pass this page number. The second one is the page size. And for now, we will hard code this page size with 3. But we can also make this dynamic by accepting this parameter as well from the client. The third argument is related to the sorting, so we need to provide the sorting information. For that, we need to use sort. And here you can see different methods in sort as well. Sort.sort, sort.by, which accepts the order. And for this demo, we will use this method, which accepts the direction, which is ascending or descending. And the second argument is the property that we want to use in the sorting. So let's use this one. The first argument is direction. And because we are receiving the direction from the client as part of the API call, instead of hard coding the direction, we will use direction.valueOf, and here we will pass it as direction dot to uppercase. So that means whatever value we receive from the client, we will convert it to the uppercase, and then that value will be used to find the direction, whether it is ascending or descending. And the second argument is the property, which is this order by. And once we have the pageable, we can use the repository to find all the records by using this method findAll, which accepts the pageable. So we will pass this pageable here. And this method returns a page object, which is actually a collection, so we can call stream on it. Let me copy the same code to convert the task entity to a collection of task detail. And then we can return the collection here. We need to change the return type now. Okay. And in the same way, we will return the response from the controller. Okay. So the method implementation is ready. Let's try this implementation as well. I will start the application. The server is up now. We need to add the records first because the data has been wiped out. So let's add the records first. And now we can try the new endpoint, which is the subset. Let's change the URL to subset. And because all the parameters for this endpoint in the controller are optional, so we don't really need to provide anything. And if we don't provide anything and hit send, what happens? Let's verify. So in the response, we only got 3 records, which means the first page, because the page size is 3 and we have total records 6. So in the first page, we only got 3 records. So that means paging is working fine. As for the sorting, the records have been sorted in the ascending order of title, which is as expected because that's what we defined in the controller in the form of default values. We can change that. Let's say we want to sort the collection based on the priority. So we can pass this priority column. In the order by field, we need to pass the request parameter. The key would be order by and the value would be priority. And this time, if we send another request, we see 3 records because there is no change in the paging. But if you notice the ordering, we see 3 records in the order of priority, in the ascending order of priority. We can change the direction as well. For that, we need to add another parameter, direction, and we can say descending. Hit enter and we see 3 records in the descending order of their priority. So we see 5 first, then 3, then 3. And keeping the same order, if we change the page as well, if we say get me the second page, so we can pass another parameter, page, and we will say second page. So this time we would see remaining entries in the descending order of their priority. And this time we see different data set, which is 3, 2, and 1. So that means the sorting is working fine and the paging is also working fine. And in the same way, we can implement the remaining methods to complete the CRUD operations like delete mapping and put mapping. All we need to do is we need to accept the required parameters and then we need to call the repository accordingly to filter the records or to update the records or to delete the records. So that's all for this video. In this, we developed a simple Spring Boot API with database support and we use Spring Data JPA to communicate with the database. See you in the next video. Thanks for watching.